Automatic question answering. In this lecture, I will consider non-factoid based question answering and current research on non-factoid based question answering systems. Actually, non-factoid based question answering systems generally contains why and how to type of questions. For example, why sky is blue and how to achieve this type of task or such type of things. To answer such questions, it is not easy to answer such questions. For example, suppose we have a complete Wikipedia document set. Complete Wikipedia dump size 40 GB and we want answer like why sky is blue. Then it is very tough to answer such kind of questions because answer of such questions may be a single sentence or maybe some group of sentences or any paragraph. So the first task will be identifying the candidate documents which make or set of candidate answers, and after that at a next step identifying or ranking the answers based on the nearness of the given question. So this is a two-step process, and actually the answers of these questions contain a reason or a cause, and in majority of cases answer do not have a high lexical similarity with question. For example, suppose we ask question like why sky is blue, then the reason behind blue color of sky may be like scattering or some other things. So scattering of air or some other situations, and these are not directly related with blue color. So just depending upon the matching or lexical similarity may not give the appropriate answer. Even linguistic feature fail to identify the answers correctly. The task of answering why and how to based questions has been treated as a difficult task due to the low performance of various systems suggested in the past. Additionally, due to the variability in the length of answer, higher difficulty level and pragmatic nature, the task of why and how to based question answering become a challenging task of significant interest. Why and how to based questions have been less explored when compared to the factoid based question. We already discussed the factoid based question contains the questions like what, where, when type of questions. Now I will discuss one of the paper of this area. So basic motivation behind this paper is based on the observations that in most of the case tendency between the why questions and their answers are like this. Means if something undesirable happens, the reason is often also something undesirable. So this is the relation, and if something desirable happens, then reason is often also desirable. This is another relation. So this is the basic motivation. Now it will clear from this a questions given and candidate answers A1 and A1 For example, why does cancer occurs? First candidate answer contains the answer like carcinogens such as nitrosamine and benzopyrene may increase the risk of cancer by altering the DNA cell. Here, if we analyze this answer, then we will get information that A11 describes the undesirable event related to cancer. Means something undesirable happens, then some undesirable things are behind. Now the second is some desirable happens, then reason is often desirable. So second answer, maintains a healthy weight. Maintaining a healthy weight may lower the risk of various types of cancer. While A2 suggests desirable action for this prevention. So our hypothesis suggests that this is more appropriate, because according to the author's hypothesis, if something undesirable happens, then reason should be answer should contains or sends something undesirable. So here something undesirable things are given with respect to some undesirable things. So according to these motivations, A11 will be the most suitable answer. So according to this, if this hypothesis holds, then we can obtain a significant improvement in the performance of Y question answering. So it is based on such kind of concepts. Means there are two concepts behind: undesirable happens, then undesirable reason; desirable happens, then desirable reason. Motivation 2. There are often a significant occasions between lexicosemantic classes of words in a question and those in its answer sentence. For instance, question contains concerning disease like given often have answers that includes the reference to a specific semantic word classes such as chemicals, virus, body parts, and so on. Second part is capturing such statistical correlations between disease and harmful substances may lead to the higher way of question answering performance. The third point is, for this purpose, the proposed method uses the classes of semantically similar words that were automatically acquired from the large web corpus and EM based clustering methods. So the second observation or second motivation is based on the capturing of semantically related information in answering. Means lexicosemantic classes of words in the questions and those in the answer sentence. Now the approach is this is a two-step process. The first step, it is taken by some other paper like Murta ETL 2007 and Fukumoto ETL 2007. The first step is the answer retrieval step. It extracts the set of answer candidates to a Y questions from 600 million Japanese web corpus. The answer retrieval is same as the best perform based on the, and second step is the answer re-ranking. Means first it identifies some set of candidate answer and then re-rank those answers. Now how can we identify the answer? Suppose we have a question like why does cancer occur? Then the first thing is to retrieve the candidate documents which may contains the answer for occurrence of the cancer. So the given system use Solr to retrieve the documents from 600 million Japanese web page corpus for a given question, given Y question. For that, suppose we have a set of words like cancer, occur, Y, then it represents it as a set of words, and then apply two type of Boolean queries. For example, AND based Boolean query and OR based Boolean query, and then apply the Solr. Actually, Solr is a popular open source enterprise search platform from Apache Lucene project. Its major features include the powerful full text search, hit highlighting, faceted search, and near real-time indexing, dynamic clustering, database integration, rich document, PDF handling, and geospatial search. It is highly reliable, scalable, fault tolerant, and provides the distributed indexing, replication and load balanced querying, automated failover recovery, and centralized configuration, and more. Solar powers the search and navigation features of many of the world's largest internet sites. So based on the first step is converting the question into query, where they used AND operator to connect all the words of the question. For example, the question why sky is blue can be converted as AND operator here. It can be represented as T1, term T1, and term T2, and so on. This is term Tn, and this is last n, and so on. We can use OR also, and based on that it represents the top, it identifies the top 300 documents. Now the next part is the answer and extraction. It extracts the candidate answers from given questions. For that it uses a very simple scheme, SAC. This is a answer candidate AC for question Q is ranked according to the scoring function SQAC. Here AC represents the candidate answer and Q represents the question. Here instead of Q I have taken A. So the formula is here T represents the set of terms including noun, verb, adjective in the given questions. So T1 belongs to T, and for all T2 belongs to T. 5 into log base E TS T1 and T2, where TS, T1 and T2 can be calculated as n divided by 2 into distance between T1 and T2 into df T2, where TS distance between term similarity, TS represents the term similarity between T1 and T2, and distance between T and T2 represents the distance, the number of characters between T1 and T2 in answer candidate AC, and DFT is the document frequency of term T, and it is whether phi is equal to 1 if term document contains the term and term similarity is greater than 0, and phi is equal to 0 otherwise. So this is way to identify the candidate answers. Now the main part is to re-rank the answer. To re-rank the answer, the proposed system in the research paper uses SVM classifier. The feature for that it uses 3 types of feature sets. First feature set contains feature expressing morphological syntactic analysis of questions and answer candidates. Second part contains semantic word classes appearing in the questions and answer candidates, and third part contains the sentiment analysis. And after that there is a feature in SVM, means learning to rank. It uses the learning to rank the candidate answers. All answer candidates of the questions are ranked in descending order of their score given by SVM. Why question answering using sentimental analysis and word classes? So the features like morphological and syntactic analysis. MSA includes n-gram of morphism, words, and syntactic dependencies that has been widely used for re-ranking answers in non-factoid question answer. The proposed approach represents all sentences in a question and its sentence candidate in 3 ways. First is morphism, word phrases, and syntactic dependency. Second part, from each question and answer candidates, it extracts n grams of morphism. Morphism generally represents a word structure for a particular purpose, here used to support the question answering. word phrases, and syntactic dependencies where n ranges from 1 to 3. The syntactic dependencies n-grams are defined as syntactic dependency chain containing n word phrases. This is a simple example. Semantic analysis or syntactic dependencies, phrases, or morphological semantic analysis. This is a table. Features used in the training for re-ranker. Now the semantic word class. Semantic word classes are the set of semantically similar words. The proposed method constructs these semantic word classes by using noun clustering algorithm. It treats the syntactic dependency relation between words as a context, and clustering method defines the probabilistic model of noun-verb dependencies with hidden classes. Probability of noun-verb relation and grammatical relations between them. Simple biased probability is used. Here n is the noun, v is the verb or noun on which n depends by a grammatical relation r. Postposition, this is generally used for Japanese context, and C is a hidden class. Dependency relation frequencies were obtained from 600 million pages, and P n by C were estimated using EM algorithms. For each noun n, EM clustering estimates a probability distribution over hidden variables representing semantic classes. So here C can be calculated by using maximum argument of maximum PC by n. Is a prior probability. Sentiment analysis. Sentiment analysis features are classified into word polarity and phrase polarity features. The proposed approach uses opinion extraction tool and sentiment orientation lexicon in the tools for these features. Opinion extraction tools. It uses some opinion extraction tools like implementation of some paper. It extracts the linguistic expression representing opinion from sentences, Japanese sentences. Word polarity, to calculate the word polarity, it uses the dictionary of opinion extraction tool. Word polarity dictionary of opinion extraction tool. Word polarity features are used for identifying the association between polarity of words in the question and the correct answer. For example, why does rickets occur in the children? This is rickets shows negative polarity. Deficiency of vitamin D shows negative polarities. Cause rickets, negative polarities where negative word polarities. It is used with semantic orientation. And finally, after applying these are already used as a feature here, and based on these features, the proposed method applies SVM based classification, means learning to rank the candidate and re-rank the candidate answers and get the answers. Thanks.